We're looking at the first year core textbook and we're on mixed exercise 6, which is on circles. We're up to question 5. So I'm given 3 points, A, B and C, and I'm told they're the vertices of a triangle. And then I'm asked to show this circle passes through those 3 vertices. So I think the quickest way is just to check each of the 3 points in turn and just show that A, B and C do all lie on this circle. So it's going to be a bit repetitive, but I think quite quick and easy. So let's check A. So the equation of the circle is x squared plus y squared is 1. So if I'm subbing in A, that's minus 1 squared plus 0 squared, which is 1. So yeah, minus 1 squared is 1. So A lies on the circle. So for B, x is a half. So that's going to be a half squared. Y is root 3 over 2. So let's just check. That does get up to 1. I'm pretty sure it does. So a half squared is a quarter. Root 3 squared is 3. And 2 squared is 4. So yeah, B lies on the circle. And again for C, so now I'm looking at C. So it was, well, C is going to work, isn't it, if B works, because it's the same coordinate apart from the minus and we're squaring it anyway. But let's quickly just to do it and then try and explain that. Okay, so again, half squared is a quarter, minus root 3 over 2 all squared is 3 over 4. And then, so therefore, A, B, and C. Do need to write conclusion, but I think I can get away with just writing them all in the same conclusion. So A, B, and C all lie on the circle x squared plus y squared equals 1. Okay, and then show that the triangle is equilateral. Okay, so from showing a triangle is equilateral, I could either be looking at angles and showing that it's got 360-degree angles, or I could be looking at the lengths. And obviously with our coordinate geometry, you've done quite a lot on where you know how to find the distance between 2 points. You don't really, apart from perpendicular lines, angles don't really come into it too much. So let's go down the route of finding the 3 lengths. So let's just write the coordinates out again. So A was minus 1, 0. B was a half root 3 over 2. And C is a half minus root 3 over 2. Okay, so let's get cracking. Okay, so the distance between from A to B is going to be minus 1 minus a half all squared. So I'm just doing the distance between 2 points. 0 minus root 3 over 2 all squared. So I'm just going to my calculator. So that first one is going to be 1.5 squared. And then that is going to be 3 over 4. So I'm getting that to be 3. Okay, so BC, sorry, AB I was doing with has a length of 3. Okay, so let's check BC. So distance between B and C is going to be a half minus a half all squared plus root 3 over 2, and then just careful here, it's root 3 over 2 minus root 3 over 2. Okay, so yeah, that's going to give me 3 because, I mean, I can put it into my calculator, but that's going to be 0. And that is just going to be root 3. So root 3 squared is 3. Oh, hang on, sorry, apologies. That first one's not 3. That first one's root 3. I'm just thinking, hang on, they're not giving me the same length. Right. So I will just check all 3. So, yeah, so sorry. So far they're all giving me root 3. Not 3. Okay, and then the final side, AC. Okay, so then I just need to check AC. So obviously I'm hoping this is also going to be root 3. Let's just move it up so I can see the coordinates on the same screen. Okay, so AC, so I'm looking at obviously these 2 coordinates now. So that's going to be the square root of minus 1 minus a half all squared plus 0 minus root 3 over 2. So if you think about it, that's actually the same calculation that we did for AB, because when we square that, it's not going to matter if it's positive or negative. So you could use your calculator, but it's going to be root 3. So obviously we then just need to clarify what we've done there. So all 3 sides are the same length, so the triangle is quadrilateral. Sorry, I'm just saying words now. So the triangle is equilateral. It's also the same length. So ABC is an equilateral. So you can write it a little bit neater than that. Equilateral triangle. Okay, so right, so we've definitely proved it. Let's just double check that they didn't have a different method of doing it. No. Oh, hang on. Okay, so they've said it's 3, not root 3. So am I just doing something daft? Right. Okay. Hold that thought. Let me just double check. Is it 3 or is it root 3? So 1.5 squared plus root 3 over 2 all squared. No, I'm going to stick to my guns. I think that's a typo. I'll re-record this video if not, but I'll double check it. I think that's a typo. I think we're good. I think all the 3 side lengths are root 3. So we'll leave it at that.